Hello everyone. Today we are going to read lesson 5 Atmosphere, Composition and Structure. Hold your hand in front of your face and breathe in deeply. Now gently blow outwards towards your fingers. What do you feel? Does it feel cool and tingly? What you felt blowing past the tips of your fingers is commonly referred to as air. It is surrounded by a thick layer of gases called the atmosphere. Earth is the only planet in the solar system with an atmosphere that can sustain life. The blanket of gases not only contains the air that we breathe but also protects us from the blast of heat and radiations emanating from the sun. Earth's atmosphere is about 300 miles 480 kilometers thick, but most of it is within 10 miles 16 kilometers of the surface. Air pressure decreases with altitude. At sea level, air pressure is about 14.7 pounds per square inch. At 10,000 feet, the air pressure is 10 pounds per square inch. There is also less oxygen to breathe as we go higher up. Considering the size of the Earth, the atmosphere surrounding it is a relatively thin layer which is held to the Earth by its gravitational pull. The total weight of Earth's atmosphere is about 500 million tons and about 99% of its mass is concentrated within 32 kilometers from the Earth's surface. Composition of the atmosphere. The Earth's atmosphere has everything needed to support life on Earth. But what exactly does it contain? Let's take a look at the composition of the Earth's atmosphere. Of course, things have not always been balanced the way they are today. The atmosphere is the air that plants and animals breathe to survive. The two main gases in air are nitrogen and oxygen. Today they form about 99% of dry air by volume. The remaining 1% is mostly argon and carbon dioxide. The atmosphere also contains tiny amounts of helium, hydrogen, neon, ozone, krypton, and other gases. Nitrogen is the most abundant gas in the atmosphere. It dilutes oxygen and prevents rapid burning at the Earth's surface. Living things need it to make proteins. Nitrogen cannot be used directly from the air. The nitrogen cycle is nature's way of supplying the nitrogen needed by living things. Plants need nitrogen to grow, but they cannot absorb it directly from the air. Microorganisms in the soil and plant roots absorb it and convert it to a form which plants can then use. This is called nitrogen fixation. Atmospheric nitrogen is also used to manufacture chemical fertilizers. Oxygen is the most essential gas for living things to survive. It is necessary for respiration and combustion. Green plants produce oxygen during photosynthesis. Photosynthesis produces oxygen when carbon dioxide and water are converted into glucose with the help of sunlight. Carbon dioxide acts as a blanket and prevents the escape of heat into outer space. It is responsible for the greenhouse effect on the earth. Humans or animals release carbon dioxide. The amount of carbon dioxide released by humans or animals seems to be equal to the amount used by the plants, which makes for a perfect balance. Scientists are afraid that the burning of fossil fuels such as coal and oil is adding more carbon dioxide to the atmosphere than is being used up by plants. Deforestation is further increasing the carbon dioxide levels with fewer plants to recycle it into oxygen. This disproportionate increase in carbon dioxide causes the earth to heat up, and the phenomenon is called global warming. Water vapor is essential for life processes. It also prevents heat loss from the earth. Water vapor and dust particles are present in the lower layer of the atmosphere. Trace gases are found only in very small amounts. They include neon, helium, krypton, xenon, etc. The composition of air varies from place to place and with time. However, the composition of clean and dry air is fairly uniform in the lower layers up to a height of about 8 km above mean sea level. Structure of the atmosphere. Information received through radars and satellites tells us about the structure of our atmosphere. Earth's atmosphere is divided into 5 main layers: the exosphere, the thermosphere, the mesosphere, the stratosphere, and the troposphere. The atmosphere thins out in each higher layer until the gases dissipate in space. There is no distinct boundary between the atmosphere and space, but an imaginary line about 68 miles, that is 110 kilometers, from the surface, called the Kármán line, is usually where scientists say atmosphere meets outer space. The atmosphere gets thinner as you go further up. The troposphere is the layer next to the ground or surface of the earth. It extends to about 30,000 to 50,000 feet high, that is 8 km above poles and 18 km above equator. This is where we live and even where planes fly. Around 90% of the mass of the atmosphere is in the troposphere. The troposphere is heated by the surface of the earth. Weather phenomena such as the formation of clouds, fog, wind, rainfall, lightning, precipitation, etc. occur in this layer. The average temperature in the troposphere decreases at the rate of 1 degree Celsius per 165 meters. This is called the normal lapse rate. Water vapor and dust particles are found only in this layer. The tropopause separates the troposphere and stratosphere. The stratosphere is the second layer. It starts above the troposphere and ends about 31 miles, that is 50 kilometers above the Earth's surface. The temperature does not drop with height in this layer. Ozone is abundant here and it heats the atmosphere while also absorbing harmful radiation from the sun. The air here is very dry, moves almost horizontally, and it is about 1,000 times thinner here than it is at sea level. The lower part of this layer provides ideal conditions for jet aircraft and balloons to fly, as it is free from clouds and weather phenomena. Aeroplanes travel through this layer, which explains why clouds are seen below when one looks out of the window of a plane. The temperature remains constant up to a height of 20 km and then increases with increasing altitude. Ozone layer is found in the lower part of the stratosphere and so it is known as ozonosphere. Ozone gas is very important for us because it absorbs harmful ultraviolet rays of the sun. Chemical pollutants, especially chlorofluorocarbons, through the years have destroyed this layer. A large hole has been noticed in the ozone layer over Antarctica. The mesosphere starts at 31 miles, that is 50 kilometers, and extends to 53 miles, that is 85 kilometers high. The top of the mesosphere, called the mesopause, is the coldest part of Earth's atmosphere, with temperature averaging about minus 130 degrees Fahrenheit, that is minus 90 degrees Celsius. This layer is hard to study. Jets and balloons do not go high enough, and satellites and space shuttles orbit too high. However, scientists do know that meteors burn up in this layer. The thermosphere extends from about 56 miles, that is 90 kilometers, to between 310 and 620 miles, that is 500 to 1000 kilometers. Temperature can go up at 1500 degrees Celsius at this altitude, though one does not feel warm here as thin air does not hold heat. The thermosphere is considered part of Earth's atmosphere, but air density is so low that most of this layer is what is normally thought of as outer space. In fact, this is where the space shuttles fly and where the International Space Station orbits Earth. This is also the layer where the auroras occur. Charged particles from space collide with atoms and molecules in the thermosphere, exciting them into higher states of energy. The atoms shed this excess energy by emitting photons of light, which we see as the colorful aurora borealis and aurora australis. The lower part of the atmosphere is called ionosphere as it has ionized molecules. This layer reflects low frequency radio waves back to Earth, thus aiding long distance communication. The exosphere, the uppermost layer, is extremely thin, and it is here that the atmosphere merges into outer space. It is composed of very widely dispersed and light particles of hydrogen and helium. It goes all the way to 10,000 km above the Earth's surface, and temperatures here may reach up to 4,500 degrees. Man-made satellites orbit the Earth in this layer. The density of the air is very low. The structure of the atmosphere dictates the way the atmosphere behaves and controls the weather that develops near the surface of the Earth. In troposphere, as altitude increases, air pressure decreases. As altitude increases, temperature decreases. Atmosphere, a big blanket. The atmosphere protects Earth like a big blanket of insulation. It absorbs the heat from the sun and then radiates the heat towards the surface of the Earth, keeping the Earth warm and habitable but not hot. This is called the greenhouse effect. It also keeps the overall temperature of the Earth fairly steady, especially between night and day. So we do not get too cold at night and too hot during the day. Without this blanket of protection, we would be baked alive by the heat of the sun during day and get frozen during night. Atmosphere has a layer of ozone. This layer protects the Earth from sun's harmful ultraviolet radiations. Atmosphere also allows light and sound to pass through so that we can see and listen. The atmosphere also shields us from meteors. This big blanket also helps to form our weather patterns and climate. The weather keeps too much hot air from forming in one place and causes storms and rainfall. The water vapor gives rise to the water cycle. All of these things are important to life and the Earth's ecology. So it is this mass of air that has made the conditions on the Earth supportive to life. So this was the reading of our lesson 5, Atmosphere, Composition and Structure. If you have any doubt or query, you can ask me in the comment section below. Also, you can find the links to other lessons in the description box below. Thank you everyone.